My name is Dr. David James. I'm a sports engineer. I work for Sheffield Hallam University. A really good example of where there's loads of engineering and a bit of sports equipment is a mountain bike. It's just full of engineering. Mountain biking's developed into a very fast, very sort of aggressive sport, and the equipment that we need to withstand the forces and the impacts that the bike goes through has to be very high tech. What it's about making a bike that's strong enough and yet still light, and that allows mountain bikers to go faster and faster, to ride down more aggressive terrain, and really it's pushed the sport forward an awful lot. Back in the old days, mountain bikers were quite limited by what they could do because of the bike, and the mountain bikers themselves started to exceed what the bikes could allow them to do, and now bikes are just catching up. There's loads of engineering in mountain bikes, but another sort of cycling there's lots of engineering too is that of road cycling. So road bikes are, they're still bikes, but they have quite different criteria for the things they need.
I'm Jos van Veldhoven. I'm 25 years old and I'm a bike messenger. And what I do is I deliver packages in and around London, which involves a lot of riding through traffic on my bicycle. My bike's my main tool to do my job. My bike is designed basically as simple as possible so that the maintenance costs are low. It doesn't even have a brake because it's a fixed wheel bike, so you can brake on your rear wheel with your legs. A fixed wheel bike basically means that as long as the chain keeps moving, the bike keeps moving as well, and your feet, so you can't coast on it, but it's really easy to control. These so-called track bikes are a little bit shorter as well than normal road bikes, so they're more easy to navigate and to cut really sharp corners. So the frame is made of oversized aluminium tubing, which gives them greater stiffness. I use a chain tensioner to pull the wheel back and to maintain the tension on the chain. There's only one ring in the front and one ring in the back. Also at the back, you can have a cog on both sides, so you can change between gear ratios you want. And these are the pedals I use. Really strong, well-engineered pedals where I can click into on both sides. I don't have any brakes because this bike is engineered as a track bike, and it's not suitable to put a brake on. But that's why I have these handlebars, because I can vary my position on them. I can hold them here, lean forward, and then use the rear wheel to brake with.
Okay, so this is my bike. It's a bit muddy, it's a bit battered, but we helped to design this quite a few years ago. First things, you've got really sort of grippy tyres, heavy tyres that grip the track and don't puncture. We've got these really good, strong disc brakes which give us our ability to stop without skidding. Then you've got things like a big, strong suspension fork which takes up all the shock. But there's some tricky things here. Because we've got such a big fork here, and that hits these rocks really hard, what it tends to do is it will flex the frame, and it can bend the frame really easily. So here we had to engineer a very sort of strong area around the bike, and you do that by having these special tubes which get very fat as they come into this bar, and it just gives it the strength that you need. Some other really important things that are going on is this suspension here. So this keeps the back onto the ground, and it gives you that ability to go fast and to absorb the shocks. So you see it moving up and down there. And this was really complicated. You had to do loads of calculations to get this right, because what actually happens is as the bike goes down, the rear wheel here actually pivots around this point here. And that means that this chain stays the same length all the time, and that helps the chain to stay on. So that's really clever, that.
I don't use suspension on my bike because it's aluminum, so really stiff, and you don't want to compromise on that, on the way it handles and the way it feels just by having a suspension fork. It would just absorb a lot of my energy that I need to get through the day.
My name is Keith Noronha from Reynolds Technology Limited. We're a company from the bike industry dating back to 1898, and our speciality is materials for bicycle parts. On this kind of material, we've got, for example, an aluminium alloy, very ductile, used in this case what's called hydroforming, so you get a really quite interesting shape out of it, which is what an engineer of a frame would want. Something like this material, magnesium, very, very low density, not as strong, but it does have excellent vibration damping properties. But here's an example of something that has to be bonded into an aluminium joint, because welding of magnesium is very difficult to do. And in fact, that does allow us, however, to also combine it with carbon fiber. Steel alloys were very traditional in the bicycle industry and actually coming back to the fore, because now you've got some materials here which are very, very strong and actually allow people to have very high impact damage, which is great, for example, for a BMX or a very high-end road frame.
If you want a carbon fiber track frame like this, it'd be new, it would be like £2,000 to £3,000 if you want a really good one. I prefer an aluminum bike because it's really stiff and it transfers the power really well. You're always looking for a balance between the price and the quality of the components, because I'm doing over 300 miles a week, so it's really important that the parts I use are well engineered.
In sport, there's always equipment, and when you've got equipment, you can use engineering to just make it better. And in sort of the world of sport, where things are very competitive, if you can use sort of engineering to your advantage, you can really do great things.